Right, good afternoon. Welcome to my talk on building a self-service Hadoop platform at LinkedIn with Azkaban. So a little bit about myself. I am a software engineer on the Hadoop development team at LinkedIn. I'm one of the main contributors to Azkaban, and previously I worked on Microsoft where I worked on the Windows kernel. So I want to start by talking a little bit about how we use Hadoop at LinkedIn. About half of our Hadoop usage is in ad hoc queries, queries for general analytics, and the other half is in the vast majority of our data products. So here are 2 pages from my LinkedIn experience. We have the home page on the left, and on the right we have my profile page. The features on the page that are directly powered by Hadoop is everything in blue. So these include things like people you may know, recommendations, and many other features. And this also includes our incredibly robust A/B testing platform in which we test every single change, every placement, and every impression that make it to the site. And the sample set and test analysis are all done in Hadoop. So let's take a closer look at the LinkedIn homepage. So people you may know and ad recommendations are 2 of the data products that are powered by Hadoop at LinkedIn. Here are some visual representations of the dependency graphs of Hadoop jobs that power these 2 features. So we have dozens to hundreds of Hadoop jobs per data product, and people you may know is one of our premier data products, which was at the core of LinkedIn's membership growth. And these have to run reliably every day, and sometimes even multiple times a day, in order to provide fresh data to our users. And it is critical that they work. So here we go. So we're constantly testing and improving the workflows for all of our data products. And we have had a really high velocity of changes since the beginnings of data products at LinkedIn. And this is a graph representing one of our major data products back in 2009. So as you can see, it's fairly small. It's not that many Hadoop jobs, and it's fairly not too difficult to understand or maintain. But back then, we were in a phase of rapid growth, and we still are today. And as we grew, these workflows changed, and they changed a lot. So every image here represents about 1 month of change to the workflow. So every month you have, you can see that there are some small changes to some pretty huge changes made to the workflow. And it got very complex very quickly. And this is just for one of our data products. Imagine having one of these for every product. It became clear that without being able to visualize what your workflow looked like and how it ran, it was very difficult to understand what the whole workflow did and to keep up with this really rapid pace of development. And so it was this in mind that we created Azkaban, our workflow scheduler, back in 2009. And this is what it looked like back then. It was pretty Gothic looking, but it had the basic features that we needed. So with Azkaban, you could run workflows, you could schedule jobs, you can view the job history, and you had other features like failure notifications. But most importantly, it had a very easy to use web UI and visualizations that showed you what your flow looked like and how it ran. It wasn't perfect though. It was just one server. It stored everything in flat files on disk, and it ran every job as a fork local process. It didn't really have user management, and the UI was engineer designed. It was a bit dark and gloomy. But nonetheless, it was heavily used, and because above all, it was simple and easy to use. So about a year and a half ago, in order to keep up with the rapid growth, we did a major re-architecting of Azkaban. We got some help from a web dev to create a completely new and easier to use UI. And now Azkaban was now 2 separate servers, with the executor server handling the job scheduling execution, and the web server managing projects, users, and providing the UI. Now we also implemented actual user management, so users will no longer be able to overwrite each other's files. And then we also stored data in the actual database, which is also pluggable. You can either store it in an embedded H2 instance or store in MySQL. And of course, we have the brand new UI and more. We also had a brand new plugin system. And so Azkaban now no longer had any dependency on Hadoop's code base at all. We modularized many components of Azkaban and turned them into plugins. And there's only one built-in job type plugin, which is a command, which basically runs a command line job. All the other job types became plugins, such as Java MapReduce, Pig, Hive, and others. We also supported non-Hadoop job types like Teradata and Voldemort build and push. We also introduced Viewer plugins, which you can use to extend the Azkaban UI to integrate new tools. And these include our HDFS browser and Reportal, which I'll talk about later. So this means that we do not run a fork of Azkaban internally. We run the same code that lives in the open source repository on GitHub, and all LinkedIn-specific code were now implemented as plugins. And over time, we found that our users use AskBand as more than just a workflow scheduler. They use AskBand as not only as a major tool for developing Hadoop workflows, but also debugging them with some of the integrated tools and the flow logs and job logs, and only going to the job tracker page when it's absolutely necessary. They use AskBand to browse HDFS, and most of our users don't even know that the name node actually has its own HDFS browser. And so AskBand to become not just a workflow manager, but the main front end to Hadoop at LinkedIn. So with this in mind, at the beginning of this year, we released AskBand 2.5, focusing on making AskBand easier and more powerful to use, as well as being more productive to develop and extend. We rebuilt the UI to be both familiar to our users and to be more beautiful and more intuitive. And by using Bootstrap, we also made it more future-proof and easier to extend when we add new features to it. We also added a number of new improvements to AskBand. We added more powerful workflow features like embedded flows. This is where you can embed and reuse flows as nodes within other flows. We also added a number of new self-service tools to help users better understand their flows and make it easier for them to debug and tune them. We added Vero plugins that were specific to job types, which means that you can build tools that are seamlessly integrated in the job details page that are specific for different job types. And we use this to build some of the self-service tools, which I'll talk about later. We also made a number of improvements to the HDFS sphere. We made it possible to view the schema in addition to the content of a file. We also added support for new formats like Parquet. We also had a number of under-the-hood improvements and more. And one of the major reasons why we pushed ease of use and simplicity so much is because of our users. And our users not only included software engineers and data scientists, but also analysts and product managers who were creating, modifying, and scheduling Hadoop workflows. So AskBand started off as just a workflow scheduler for Hadoop. Today, it is also an integrated runtime environment where users can develop and run complex workflows consisting of Pig, Hive, and MapReduce and other types of jobs, as well as a unified front end for Hadoop tools. So in the first year, we had about a dozen different workflows to manage and a handful of people that use them. Over the last 4 and more years, we've grown to have over 1,000 different users. We have AskBand instances running on now over 6 different clusters. We have 2,500 flows accounting for the 30,000 different jobs executing per day. And we have jobs that run from just a few minutes all the way to about 8 days. Well, the bad news is that we have over 1,000 users, 2,500 flows, and 30,000 jobs running per day. And this is only going to keep increasing. It really surprised us how much AskBand is being used. And these numbers are only from one of our instances, and we have about 6 of them. In addition, our Hadoop development team is fairly small. We only have about 8 people. So to keep up with our users, we had to make our Hadoop infrastructure as self-service as possible. And the primary front end to our Hadoop infrastructure is, of course, AskBand. So how do you use AskBand? So I'm going to show you how easy it is to create an AskBand workflow. A workflow is simply a collection of job files. These are key value property files. And here I can use the type property to define what kind of job I want to run. And I can run a variety of different types of jobs like Pig, Hive, and Java, or even plain old command line jobs. The dependencies parameter is pretty self-explanatory. It specifies which jobs must successfully complete before this job can run. And the rest of parameters are passed to the executing job itself. And all AskBand does with these parameters is to construct a process which is run locally. And the reason why we can get away with running a lot of processes locally is that most of them don't do much more than spawn Hadoop jobs on the cluster. And so in this case, we have bread which waits on peanut butter jelly, making this the most delicious workflow ever. We found that many of our users reuse what is effectively a subflow several times with different parameters. And so as a result, we added support for embedded flows, making it possible to embed a workflow as a node in other workflows. So here I just set the type to flow and set flow name to the name of the workflow that I want to embed. So in this case, my embedded flow is sandwich consisting of peanut butter, jelly, and bread from the previous slide. And this waits on coffee and fruit, making this workflow a complete and healthy breakfast. And afterwards, I just package up my jobs into a zip archive and upload to AskBand using the web UI or the REST interface. And here's a project page where I can run my workflows, set permissions, and customize my jobs. If I want a bird's eye view of which jobs make up the flows in my project, I can click the drop down for one of my flows, and I can see a hierarchy of its jobs in outline form. And then when I mouse over one of these jobs, Aspen automatically highlights the jobs that it depends on and the jobs that depend on it. And when I'm ready to run my workflow, I just click the execute flow button, which brings up the flow execution panel. So here I can do a lot of things to customize my flow before I run it. So I have this beautiful visualization in my flow where I can enable or disable any part of it. So for example, I have 3 embedded flows here in the final flow that pushes data back to the front end. So if I want to test my workflow and not push any data, then just right-click and disable the last flow. Because the flow will take a long time to run, I want to be notified with email if the execution fails. So I just click the notification tab and select to be notified when the first job fails and specify the email address I want the notification to be sent to. I can also set the failure notification to be sent after the entire flow finished running, or I can just set a notification to be sent if it finishes successfully. And by default, if a flow fails, AskBand will let or if a job fails, AskBand will let the currently running jobs finish before killing the flow itself. But when I'm testing my flow, I might want to change that behavior of when the failure is caught. So I can click on the Failure Options tab and select which behavior I want. And so aside from letting the currently running jobs finish, I can also have AskBand kill all the jobs immediately when one of them fails, or I can have it continue running as many of the remaining jobs as possible. And I can do all this through the UI. I can also customize the execution of my flow by setting custom parameters. I can click into the Flow Parameters tab and set any parameters I like. And the parameters I have here will override the parameters set in my job files. And this is particularly useful when I'm testing my flow. And finally, I might want to run multiple instances of my flow concurrently. And this is often useful when I'm testing it and I want to kick off a few instances, each with a slightly different set of parameters. But if I'm concerned about the different instances of the flow stepping on each other or touching the same files when running in parallel, I can go into the Concurrent tab and specify how I want the workflow to run if one instance is already running. And I can either disallow concurrent executions altogether, I can just let all the instances of the flow run concurrently, or I can pipeline them in specific ways to ensure that new executions will not overwrite the current one. For example, I can block the execution of job A in one flow until the previous flow's job A has finished running, or I can block job A until the children of the previous flow job A has completed. And this is useful if I want to make sure that my flows will be a few steps behind one that's already executing. So now when I run my flow, I'm presented with this interactive visualization of it. And so at one point, Hadoop users had to refresh the job tracker page every few seconds to see the status of the job as it runs. And we try to do better than that. Instead of having to sit there and click refresh every few seconds, AskBand visualizes the execution of the flow automatically updating as the jobs run. And here I even expand into the embedded flows and view the progress of the inner jobs as well. And if I want to look at which jobs are being run at which point in the flow's execution, I can also click into the job list tab and view it as a Gantt-like chart. And this is also updated automatically as the workflow runs. And then here I can also expand into the embedded flows as well. And I can also click into the details link for any of the jobs and drill down into the job logs and other details. And oftentimes at LinkedIn, Hadoop users will have AskBand open to this page on one screen while they develop their flows on the other screen. And this is how we make it easier for users to understand their workflow executions, and this is critical to helping them understand their workflows as a whole. So many of our Hadoop workflows are scheduled to be run repeatedly, either monthly, weekly, or even daily in the case of some of our ETL workflows. And AskBand makes it really easy to schedule our workflows to be run at specific time, date, and recurrence. And if I want my workflow to run at 5:30 p.m. every Friday, I just click Schedule and bring up the Schedule Flow panel. And here I can specify the time, the date, and the recurrence of when I want my flow to be run. And once my workflow is scheduled, I can view it on the Scheduled Flows page. I can also manage other flows I've scheduled from this page as well. But what about the times when one of my jobs may be running abnormally long, and we have a feature for that too. I can click on Set SLA for any of my scheduled flows and bring up the SLA options panel. And here I can set the SLA settings for my entire flow or individual jobs in the workflow. I can set notifications and also, or even kill my job if the SLA is exceeded. So the other side of developing Hadoop workflows is debugging and tuning their performance. As we know, Hadoop, Pig, and Hive are all very complex systems with many different knobs and logs that provide a ton of information but are not always easy to find or read. So again, with over 1,000 users, several clusters, and so many jobs executing per day, as well as a small Hadoop team, we need to build tools to make it as easy as possible to help our users debug problems and tune the performance of the workflow and jobs on their own. So as my jobs change over time, one thing that I want to know is how the new changes affect the performance of the job. So on the job history page, Aspen provides this nice time graph visualizing the history of a job's runtime. And I can mouse over and click on any of the data points to view the details and the logs for that particular execution. And we also added the same time graph for visualizing the history of runtimes for the workflow as a whole. And so this way, as I make modifications and add new jobs to my workflow over time, I can easily see how the performance of the modifications will change the runtime. Another important feature of Azkaban is that it provides all the job logs so that you don't have to hunt them down. And job logs contain very rich information. For example, Pig and Hive jobs provide tables describing the numbers of mappers and reducers and task runtimes for the map-reduce jobs that they fire off. But the job logs can be very verbose and are not always easy to read. And one complaint we get very often is that the headers on the tables of job stats never line up with the actual columns. So as a result, one of the new self-service tools we added in Azkaban is the job summary. The job summary parses the job logs and extracts information most useful to the users, things such as the command used to run the job, the class path, the JVM options, memory settings, and parameters passed to the job. And for Pig and Hive jobs, it displays a table of mappers and reducers in an actual table. At Linkdin, the majority of our Hadoop jobs are Pig jobs. And as we know, Pig scripts are ultimately compiled into DAGs of map-reduce jobs. And when developing and tuning Pig jobs, it's very useful to be able to visualize those DAGs. And as a result, we built a Pig visualizer, which is a plugin specific to the Pig job types. As you can see, the UI for the Pig visualizer is seamlessly integrated into the same, basically the same set of tabs as the job logs. And so the Pig visualizer uses the Pig listener interface to collect stats about the Pig job as it runs. And it visualizes a planned DAG and provides detailed information about each job that previously required going to the job tracker for. And this is pretty similar to Lipstick and Ambrose, but this is completely integrated with Azkaban. You don't need to modify your Pig job at all, and you don't need to leave Azkaban to go to a separate tool. And I'll show you some of the things you can do with a Pig visualizer. So here I can select one of the nodes, which will display some information in the sidebar. And these include the types of operation used, aliases, whether or not the job succeeded, a job tracker URL, and some stats. And clicking on more details will bring up this modal, which displays more detailed information about the job. So the first tab displays the Pig job stats, which are provided by Pig. And these include stats about the mapper and reducer, counts and runtimes, some I/O stats and a spill count, and also like if the job reads or writes any files, which files are read or wrote to, and how many records. The second tab contains the Hadoop job counters. And these are the same counters that you would find on the job tracker page. But again, you can view them here, right here in Azkaban, without having to go to a completely separate tool. And finally, the Pig visualizer displays part of the job configuration as well. And so this is a subset of the job conf. The values we picked to display on this page are the ones that our users found most useful to look at when tuning the Pig jobs, and things like split size and IO sort MB, compression options, and even we also added the Pig map and reduce plans converted from base64 to text. And of course, there's a convenient link to view the full details on a job tracker if you need to. And often, users want to better understand how the workflow is performing as a whole and find out more information like which jobs are running the longest or using the most number of tasks. So we built another tool called the flow summary to provide a dashboard of details and stats for a given workflow. So at the top, we have the project name and the list of job types that the workflow uses. And then we have some information about scheduling. And here I could even remove the schedule or set the SLA right from this page. And then we have the flow summary can analyze the last successful run of the flow and display an aggregate view of the stats from all the jobs. And so first it displays a histogram of the runtimes for each of the jobs in the flow. And then below that, it shows aggregate views of things like resource consumptions, like which job used the highest number of mappers and reducer slots and the total slots used. And then it also shows which jobs set the highest values for some of the resource parameters, such as the XMS or XMX, and which jobs use the most distributed cache and so on. And also it shows which jobs read and or wrote the most number of bytes. And so in these tools, especially the pig visualizer, have been heavily used at LinkedIn and have been really helpful for users to better understand and tune their workflows and jobs. So next I want to talk about our HDFS browser. So browsing HDFS is something that we do extensively when developing Hadoop jobs. And we made that really easy to do with Azkaban using the HDFS Viewer plugin. So browsing files is really easy. The HDFS browser works like any other web-based file browser. You can jump back to any parent folder in the path and easily go to your home directory. And oftentimes you want to be able to view files in HDFS, but the files may be in a binary format. And at LinkedIn, we store most of our data in Avro, and there are some here and there that are stored in formats like binary JSON. While tools like the NameNode HDFS browser and the Hadoop command line DFS tool can let you browse HDFS, they don't really have good support for viewing binary formats and simply dump the raw contents of the files. And having to write your own Hadoop jobs just to view the contents of the file is pretty cumbersome. So we made that really easy. The HDFS browser has pluggable file type viewers, which will parse the files in different binary formats and display up to about 1,000 records in human readable text. But sometimes we want to be able to see the schema of the file as well. We also made that really easy to do. So in this case, you just click the schema tab, and the file viewer will extract the schema from the file and display it as a readable text. And currently, viewing the schema is supported by the Avro and Parquet file viewers. And in total, the HDFS browser supports a number of different formats, including Avro, Parquet, binary JSON, sequence file. You can even display images, and some of our users like to have a job at the end that creates a visualization of the results and save the image to HDFS, and then they would view the image in the HDFS file browser. And of course, it could also display text. So as I mentioned before, Hadoop is heavily used by analysts at LinkedIn. And often analysts want to simply be able to write a query and schedule it and get the results without having to jump through the hoops of uploading job files. And we made that really easy to do with Reportal, an easy reporting tool which is built on top of Azkaban. So this is the main dashboard of Reportal. From here, I can manage my existing reports or schedule them. I can also create a new report. And creating a new report in Reportal is really easy. For this report, I want to find the 10 most common words in the book Alice in Wonderland. And as you can see, so Reportal provides a nice editor that has syntax hiding. And so once I have my query, I can just run the report, and then I can view the results. And I can download results, or I can even visualize them using a line graph, bar graph, or even a pie chart. And Reportal currently supports Pig, Hive, and Teradata queries. And Reportal is completely built on top of Azkaban and uses Azkaban to execute and schedule jobs. The UI is another viewer plugin, and each of the job types that Reportal supports is an actual Azkaban job type. And Reportal is heavily used by analysts at LinkedIn for simple reporting. So now I want to give a sneak peek at some of the upcoming features that we're currently working on. So the first thing we're working on is a Azkaban Gradle plugin in DSL. So having lots of job files becomes more difficult to manage once you have more and more jobs in your workflow. So we made it easier to define Azkaban workflows by creating a DSL, which is implemented as a Gradle plugin. So you can describe your Azkaban flow and deploy it with Gradle. And then you can have everything be in one single file, or you can have multiple files if you want. These will compile to job files. So in this example, we have the Azkaban configuration, and we define a workflow consisting of a pig job and a hive job. And we also have a static checker for this plugin, which will statically check your workflow to make sure that you don't have things like circular dependencies and things like that, which previously required actually uploading to Azkaban to check. And of course, this is also valid Groovy code, which means that you can add conditionals for say, if you want to add specific jobs when you deploy to development versus when you deploy to production. And this plugin will be open source, so stay tuned for that. And these are some of the other features that are currently on our roadmap. We want to add new visualizers to support Hive jobs or even test jobs. And we also are exploring the option of integrating Lipstick itself into AskBan. We want to be able to support the DSL from other tools, since not everyone uses Gradle. We want to add some operationalization tooling around AskBan and some more improvements for monitoring. We want to add scalability improvements, because one thing that we found was that as we have more users, then the load on the AskBan servers become greater. We want to be able to scale out AskBan better. And we also want to improve plugin interfaces to make it even easier to build new plugins and build new tools that integrate with Azkaban. And here are some future ideas that we've been discussing. Some of these include conditional branching, where you can have a node that will in your flow that is conditional on different inputs and will either run one or the other flow in its children. We are discussing adding a Hive Metastore browser, something similar to the HDFS browser, but letting you browse the Hive Metastore. We are thinking about pluggable executors, such as launching Yarn containers. We also are looking at adding a persistent storage server to make it more efficient for AskBan to store projects and store stats and other data. And we're also looking at launching and monitoring long-running Yarn applications, such as SAMs or Storm jobs. And what's interesting about this is that, since these jobs pretty much don't really terminate, they don't really need a scheduler, but it'd be nice to be able to visualize how they run as they're running. So I want to give some special thanks for our contributors. That includes Heen Liu, who is now the lead developer of AskBan Linkdin, Anthony Su, who's been working on Reportal, Alex Bain, who's been working on the AskBan Gradle plugin, Richard Park, who basically did the AskBan 2.0 rewrite, implemented embedded flows and many other changes to Azkaban. Chen-Jay Yu, who worked on AskBan Core, the trigger manager, and some of the job types, and Shida Li, who created the Gradle plugin for Azkaban. So Azkaban is available on GitHub. As I said before, we do not use a forked version internally. We run the same code internally on the clusters that live on the GitHub repository, except for a few LinkedIn-specific plugins. So please check out our website and our source code on GitHub, and we look forward to you giving Azkaban a spin. And we always welcome your feedback, your bug reports, and pull requests, and we love to get new contributors as well. So thank you very much. Any questions? Can you please come up to the mic if you have questions? Yeah.
Hey, great presentation, and it looks like a really cool product.
Thanks.
I was wondering, have you thought about making a job conditional on success or failure? Because you could do conditional workflows by just having a job that checks whatever condition you want, and then you could have some workflows that get triggered by failure rather than success.
Right. Some of our users have sort of worked around that by looking at outputs of a previous job. But that is one of the features that we are planning to add to AskBan, to be able to have a node that's conditional on success or failure of a previous node.
Cool, thank you.
Thanks.
So my question is, say if you have a workflow that's running and then AskBan instance suddenly down, you bring back the server, what happened to that workflow?
So your question is, if you have a workflow that's running and then AskBan goes down, and then when you bring it back up, what happens to the workflow? So right now, if the AskBan server goes down and then you restart it, you have to restart your workflows as well. Or it will restart all the workflows that was running before.
And what if there's a workflow running, AskBan itself is up, resource manager goes down, you bring back resource manager, what happened to that workflow?
So AskBan doesn't actually run on Yarn, so it doesn't really use the resource manager.
Oh, so right now AskBan is only running on Hadoop 1, is that what you're saying?
No, actually AskBan is its own server. It doesn't have any dependency on Hadoop at all. So there's the executor server, which launches a local process, which then launches Hadoop jobs on the cluster.
But when you run on Hadoop 2, don't you need to negotiate resource with Yarn? And
yeah.
Once resource manager is down, when you bring that back up.
Right. So that's up to the the Hadoop job that Aspen executes. So Aspen itself doesn't really interact with Hadoop at all, like whether it be a job tracker or the resource manager. It fires off a Hadoop job, and the Hadoop job is usually a job client to talk to like the job tracker or resource manager to launch the job.
Okay.
So it's up to the job.
Yeah, my last question is Aspen highly available?
So that's also one of the features we're talking about. It is right now it is not really highly available, but we are looking at adding that.
Okay, I see.
Yeah.
Thanks.
The SLA function that
Right.
you have built, and great presentation, by the way, it was fantastic.
Thank you.
That SLA function, does it actually enforce Hadoop to perform a job in a specific set of time, or is it more of a suggestion?
Is more, so basically, it would either notify you if your job is taking longer than the SLA you set, or it would, if it exceeds it, you can also have it just kill the Hadoop job. If it
Okay, so
takes
but
too
it's
long.
informational. It's not actually forcing Hadoop to construct that MapReduce job goes before this MapReduce job, et cetera.
No, it's not.
Excellent. Cool. Thanks.
Hi.
Hi.
My question is about API. Are there any kind of API to access Azkaban, like a REST interface or to run jobs and stop jobs and so on?
Right. So there's a REST interface for user authentication, and there's one for uploading jobs. There currently is no REST interface for running jobs, but that's something that we're planning to add as part of our roadmap.
Okay.
Yeah.
Thank you.
I'm curious about like workflow aggregates or composite workflows, and along those lines, how you guys deal with things like data availability triggers. So in the event that you want to string together, for instance, a few workflows, you took the peanut butter and jelly sandwich
Right.
example there. Let's say I want to have, provide a bunch of meals based off of that sandwich. How do you guys approach that, or do you guys have a solution for that?
So for data availability triggers, so we actually have some of the functionality built in the new trigger manager that we added in Aspen 2.5. Not all of it is exposed yet, but it is on a roadmap.
Okay. So when you guys are ingesting data, into Hadoop, how does that typically work when you have a schedule? So let's say the data currently is not there. What does it typically fail the job, or how is that currently handled?
So I'm not too familiar with how our ingestion pipeline works. We can talk about that more offline if you like. I
Sure.
can point you to who would know more about that.
All right, thanks.
Hi. Given the scalability that Hadoop has internally, with Yarn and the scalability, what was the drive behind having multiple clusters with different Azkaban front ends?
So our different clusters are more used for different things. So we have a development cluster, we have a production cluster, and then we have a number of ETL clusters.
Okay.
And we also have like test clusters and stuff. So basically, like most of our users use the development cluster for creating their workflows, and then they go through a production review process. When their workflow is approved, then we give them the go-ahead to move it to production. But generally, we don't really run jobs or run workflows across clusters yet.
Okay. Well, that was my next question is,
Right.
could I create a flow that drove on, ran on one cluster because maybe some data was available there I needed, and then on another cluster because I had some data that was available there? But it sounds like no, that the answer is that's not designed for that.
So you mean have part of workflow run on one cluster and part on another cluster?
Correct, yes.
Yeah, but that's, we currently don't support that yet. One way we are thinking about supporting that is to have the same Aspen web server talk to executor servers on different clusters. So we're still we're discussing how we might do that. But right now, we don't really have that need internally. So it's not really on roadmap, but if you want that feature, then definitely check out our GitHub and open an issue for it.
All right, thanks very much.
Yeah, thanks.
Hi, nice talk.
Thanks.
Say your job fails, you're debugging, maybe you wrote some new script and it failed, or you ran out of disk space or something.
Right.
Are you able to restart it at the point of failure, or does it always have to restart from the beginning?
Yeah, you can, when your job fails, so on the flow execution page for that execution, it will show the jobs that succeeded in green and the ones that failed in red. And then when you click on schedule flow, it actually disable the ones that are in green and start from the one that actually failed.
Oh, excellent. Do you support TES?
We don't have a job type for TES yet, but I mean, it's not that hard to add one.
Okay, but
And-
you could do it through the command line job or something?
Yeah, you can do that too if you want.
Okay,
Yeah.
thanks.
Thanks.
Hi, I was wondering, how rich are the semantics of job types? And have you thought about really making that rich, like having data-specific semantics or problem-specific semantics, almost like a job template that someone can invoke so that they don't even have to, conceive of the structure of the job?
So you're talking about a template for the jobs themselves?
Like for the problem domain, the business problem domain.
Oh, you mean like a templatized pig job that?
Yeah.
I see. So that is a bit outside the scope of Azkaban. Azkaban is more of like a way to run these your workflows that consist of these jobs and visualize how they run, and not so much actually creating those jobs yet.
I'll do the plugin.
Yeah, that worked too.
You mentioned that you're able to refresh the content on the HTML page without doing click and refresh. So
Right.
how did you accomplish that?
So basically, it pulls every few seconds, and then checks the status of the jobs that are being executed, and then refresh, and then updates that page. So it's basically via JavaScript. So when Aspen is running a workflow, it basically launches a bunch of local processes, and then keeps track of which ones have failed, and then which ones need to come next. So Aspen itself checks for that. Right. So so that would be for a specific, actually I think we might already be doing that. I'm not too familiar with that part of the code base, but right.
Yeah.
Yeah, it would be pretty straightforward. We actually use something similar for the pig visualizer. We use the pig notification listener to get stats about how each of the different MapReduce jobs that pig fires off is running, and then we get that DAG that you saw.
So second question is, so now you're launching these jobs. How do you know you're pushing beyond the limit of the cluster? Like, do you have some sort of resource, your own version of resource manager that will, stop further launches until you have the current job completed?
I see. So Aspen doesn't really enforce that. That's up to, that would be up to like the job itself or say like the application that's running. But I think currently enforcing resource consumption of the jobs are a bit outside the scope of Azkaban. But Aspen could provide ways to tell you more about like how much resources your job is consuming. But overall, I think that's more of a detail specific to maybe that job type or that, say, Yarn application or whatever.
Okay. And last question is, so how does the framework provide the remote launching capability? Like, does it use some sort of agent-based architecture, or does it use some sort of SSH, command? So
that's up to the job type plugin, actually. So like for Hadoop jobs, the plugin itself will basically do what you would normally do when launching a Hadoop job, similar with Pig and Hive jobs as well. So
Okay.
it's implemented in the job type.
But so you always launch it on the same host, or can you launch on a different host?
So Aspen launches a process locally on the same host, and then that process will like basically use the logic in the job type plugin to launch the job remotely on the cluster.
Got you.
Yeah.
Got you.
Can it authenticate in a cluster
Yeah,
that it's not already authenticated in?
right, yeah, it can.
Do you have Kerberos authentication
Yes, we
integrated
do.
into that?
In terms of the workflow capabilities, do you have a comparison between Azkaban and Oozie, and what kind of features Azkaban doesn't currently provide that Oozie does?
Right. So currently, Uzi does provide more features in Aspen in terms of what you can do with a workflow, like things like, I guess, I mean, right now Aspen doesn't support like conditionals or database triggers, but those are things that we are thinking about adding to Aspen in the future. But one thing that Aspen provides that Uzi doesn't really have is a more like a very intuitive, easy to use interface to look at like what your workflow looks like. And
Yeah, the point of the question is,
Yeah.
do you see this as a replacement for Uzi? Because if the workflow part can be covered, the rest of it is definitely like 10 times better.
Yeah.
So,
Right. Yeah, but potentially, I would say yes.
okay,
Right.
thanks.
Yeah, exactly. Right. Any more questions? Thank you.